how the robot the end effectors performing the task. See here, it can lift. Dear gentlemen, again there is an interruption. I am receiving my voice. Please. Yes, special tooling for robot that enables it to perform the specific task, and an end effector is a device that is at the end of the robotic arm. We can think of the end effector like human hand. Even though a human hand is very versatile, and end effector has one great advantage that human does not have, and that is the interchangeability of the end effector. If the end effector is not suitable in the case of robots, then what we can do, we can change the end effector as per our wish. We can change our end effector, and we can do our required task. And the robotic end effector is any object attached to the robot flange that serve a function, and it is designed to interact with the environment. Device that attach the wrist of the robot arm and enable the general purpose robot to perform specific task, and peripheral accessories, robot tools, and end of tooling, tool tips, and end of arm device. The end effectors, the versatile various names of end effectors are so, and the concerning the basic types, it has two different types. One is grippers, the other one is tools. In order to perform specific task like welding or painting, we need to have the system which perform the required task. At that time, we know that there is no need to have grippers. At that time, we can install directly. We can install the system which will perform either painting or welding. At that time, it might be called as in tools, and we'll see the basic types little later once we are very familiar with the videos which is related to the grippers. We'll come back to the slides. Now we'll see the videos which will disseminate the information related to the end effectors. Yes, your the audio is clear. The the audio is clear.
Yes, sir.
Yes.
A robotic gripper is a end effector, so it's something you put on the end of a robot arm, and it helps it pick up whatever item you may want it to pick up. So the one that we've developed here is a universal gripper, so it can pick up many different items with the same gripper. The design of the gripper is very simple. It has two main components. One is this massive granular material, and we find after quite a bit of research that coffee has worked very well for us for that massive granular material, and that's encased in an elastic membrane. And for this prototype, we're using a latex balloon for that membrane. And so what happens then is you can control the pressure inside the balloon, and if you evacuate the air from the balloon, it'll contract very slightly, and the coffee will become vacuum packed and become very hard.
So this is a prototype of what this gripper looks like. What you basically have here is a party balloon filled with grains of coffee. And why did we choose these materials? It's basically, if you've ever handled vacuum packed coffee, it's as hard as a brick. But once you release the vacuum of that package, the coffee spills like a fluid. So this is what we call the phase transition between solid and fluid. We've seen it in water and ice. It's exactly the same phenomena here, but instead of atoms of water, molecules of water, we have grains of coffee.
We tried rice, we tried different seeds and beans and many different things, and we found that coffee was a very good material to use because it was irregular. So the grains did kind of interesting things and locked into each other really good when it was driven into the jamming state, that rigid state.
You know, the big leap that we've done in this project, led by Heinrich Jaeger from Chicago, was to realize that this very fundamental process can be used in robotics, and I think that's you know that's the big step. Once Heinrich realized this, then it was a question of how to apply it, the different ways, what materials work best, and so forth. You know, this is one example of applying this concept to manipulation, but you can also imagine other applications. You can imagine, for example, structures that are soft when they need to be, and they can reconfigure and then harden when they need to. So reconfigurable structures. You can imagine putting this kind of structure on the feet of a robot so that it can walk on the wall or on the ceiling and grasp things as it's walking. You can imagine putting these kinds of things on robotic tracks, on fingers. So there's really lots of ways that this kind of technology can be used, and we want to see where it can take us.
Yes. We are inspired from the human hand, and we are trying to mimic, or we are trying to imitate how a human hand works. Does it uh, perform the task, required task? Like that, we are trying to imitate, and we are trying to mimic the biological system. And this is what the developments happening in the past decades, or in the past many years, and based on the flying based on the aircraft. Have you already aware about the historical development related to aircraft and ship and all? We are inspired from the natural system, and based on that the developments happening. Here, what a chameleon or a lizard, how it perform the task, and similarly we are inspired to how a chameleon or how a lizard catches the insect which is nearer to nearer to the lizard, how it catches and how it tries to suck the insect. From that inspiration, one type of gripper is also available, that is shown in the next video. And similarly, we need to see here. Similarly, we need to watch the happenings in and around us. Then, from that, we need to learn a lot. That will give you a wide idea, even in technically, and even with socio moto also we can get many information and see. Do you think that the force required to pull or push to grip the component is uniform? The force required to take the component, take the object is uniform, and the pressure which we are disseminating to catch the component is uniform. Do you think it is so, or we need to give a different force or different pressure now to carry the different component? What was your
So
views?
yes, so I think it's different because the weight of the different objects matter. So I think the pressure and everything should be different. Then only it can pick it up.
Yes, absolutely. But how we can control those pressure or force uh,
I think
based
that
on the
through
hydraulic
the
system, or it might be an electrical system? How we can able to control those force or pressure?
so those I think it may have some sensors, or it may when it picks up, it may see that how much pressure, how much force is required, and according to that it balances itself.
Yes, that is what we are going to have. That is what we are going to learn. Great. I'll please make a note. Please make a note of these arrangements. It is a magnetic gripper. It has magnet at the bottom. And the peak, base magnet. Holding C, holding up to holding force up to 120 Newton, and that we need to convert into kg. It might be, what was the relation between newtons and kg?
12
10
kg.
12 kg.
9.81, 9.81, and or 1 kg meter per second square might be 1 Newton. Instead that what we usually do, we usually notate 1 kgf is equal to 10 Newton. 1 kgf is equal to 10 Newton, approximately equal to 10 Newton. That is equal to 9.81 Newton. Therefore, it can carry a 12 kg. What we need to do is what we need to do in order to by changing the bumpers we can change the force. By changing the bumpers we will change labs. Yarpic vacuum gripper. And this EV vacuum cleaner, and see the advantages or advantages of each this vacuum cleaner in particular, right? And the customization is we can see this as programming is good handling for the application, that is packaging, packaging is any vacuum keeper. This is universal gripper. Yes, these are the videos related to grippers. And do you have any doubts, or do you want to share anything related to the video? And do you need any clarification over the video? What we have seen, we have seen the grippers and various grippers and tools. The grippers can be classified into mechanical gripper or suction or vacuum gripper, magnetized gripper, hooks, ladles, and adhesive or electrostatic grippers. And concerning the tools, it might be a machine tool or measuring instrument, or welding torches or laser and water jet cutters. And the end effectors may be widely classified into various types according to the type of grasping ability, and according to the number of grippers mounted on the wrist and according to the mode of gripping, and according to the number of degrees of freedom, uh, and according to the source of power, it can be classified. That we need to start with mechanical grippers. The mechanical grippers usually it has 2 or 3 fingers, and concerning the vacuum gripper, the load or design is entirely different from mechanical grippers. The magnetic, similarly, we have magnetic grippers, adhesive grippers, and that is what we are going to discuss. And design of grippers, we need to have attention over the design of grippers. And before that, we need to learn about the various laws of robotics. What might be the laws of robotics? Like the thermodynamics, we have various laws, isn't it? We have zeroth law, first law, second law, and third law. Can you please remind the zeroth law of thermodynamics and first law of thermodynamics? Please unmute your mic and go ahead with the laws of thermodynamics, zeroth law and first law. Are you in the meeting? Are you attending? Is everything
Yes,
is
sir.
okay?
Zeroth law
Yes.
states that if sir, my voice is I
Yes,
can
yes. Go ahead, Sitash. Sitish, go ahead.
if two, three, how to say, sir? If A and B are in equilibrium with C, then A and B are in mutual equilibrium.
Yes. Okay. There are many things. We even we can spend 2 to 3 hours with zeroth law itself. We can spend a lot. And once time permits, we will discuss more about the various zeroth law, first law of thermodynamics, second law, and third law. And concerning yes, someone please remind the first law of thermodynamics. Any deviation from zeroth law? Zeroth law.
Energy conservation, sir.
Yes. Tell me. Very few only participating, and
It is
again and again I
energy
am
conservation,
hearing.
sir.
Yes, Gaurav, I appreciate your effort. Still, I'll give an opportunity you to discuss in some other time. Since you are attending, and Chitas and Gaurav, you and some other people. There
So
are one
first
more.
law, so first law would also include entropy equals to heat divided by constant temperature.
Very good, Sabarani. Wait. We request some other to give their participation. There are 89 people are there. Those who doesn't given participation. Aditya. Wait, Aditya. Is someone? Yes, someone. Please go ahead.
Yes, so first law states that change in internal energy is equal to change in heat minus work done.
Again. Go ahead.
So, first law states that change in internal energy is equal to change in heat input minus work done. D is equal to dk minus dw.
Yes. We'll. Yes. Similarly, we have 4 laws in robotics, and that I'll tell you. Please remember that last, and I'll tell you the last. Before that, what is mechanical equilibrium? Since Sita is talking about equilibrium, thermodynamic law, even I have disseminated the difference between the rest and equilibrium during the my numerical methods class. And please, what is the difference between equilibrium and rest? Someone remind me. Not from numerical methods.
So equilibrium is when
Wait,
net forces.
Vimulation. Someone from.
So what is the question, sir? Repeat, sir.
Difference between equilibrium and rest. Rest and equilibrium. Hari Kumar.
Sir, rest means the body will be at the velocity of body will be 0, sir. But when equilibrium means only the force and the heat exchange will be, and some mechanical equilibrium, thermal equilibrium, and chemical equilibrium will be 0, sir.
Yes, very good. Samrudra. Very good. Hari Kumar, you unmute your mic and tell me what is the difference between rest and equilibrium. You add on the values, add on the points which was taught by Samrudra. Hari Kumar. No, this is what happening. You are giving your participation, and you are unmuting. You are going, and you are doing your Karan Rahul.
Sir, like if a body is in equilibrium, it like does not necessarily. Sorry, if a body is in rest, it means the body is not moving. But a body can be in equilibrium even if it is moving with a constant velocity, or it might be at rest. Just the net of all the forces of a kind acting on a body must be identical and in opposite direction. Means they should cancel each other out so that the body is in a
Yes.
constant state.
Yes, very good. Now, Sabarani, you go ahead. Sabarani, we have given a classic difference example for rest and equilibrium. Yes, go ahead and tell me.
So the difference between rest and equilibrium.
Rest and equilibrium. Difference between
Yes.
rest and equilibrium.
Yes, so for equilibrium, the sum of forces acting upon the body should be equal to 0, and for rest, the velocity of the body should be equal to 0.
Yes, we have differentiate with some example. Are you remember?
Example. So like normal physics examples, right?
Yes.
Yeah, so if the car is not in motion, like if we don't start the car, then we'll call that at rest. And then if there is a box and we give equal forces from two opposite directions, then we'll call it an equilibrium.
Okay. Anyway.
Hello, sir.
Yes, someone.
Car moving at
Yes, sir.
constant
I think
velocity is also equilibrium.
Yes, we cannot. Yes.
so. I think
Yes.
in equilibrium there will be some force, sir, but the force will get cancelled out. But in rest there will be no force at all. So it will be there will be no force or no motion. But in equilibrium there will be some force acting on the body, but they'll get cancelled out, sir.
Yes, that is what I have initiated. Yes, very good. And you think there is in body, and there won't be any disturbance, external disturbance, and it should be in rest. If it is not if it doesn't have any disturbance, it should be rest. That is said to be rest. A body doesn't moves depends on the other object. That is said to be in rest. Even after applying a force system, the body remains in the state of rest. That is said to be an equilibrium. The difference between fasting and starvation. Fasting and starvation. That was the difference between rest and equilibrium. Okay, we'll talk about the once the time permits. We'll little more. We'll talk about the laws of motion and all. And laws of robotics. We have 4 different laws. That is zeroth law. What it says is a robot must not injure humanity, though inaction allow humanity to come to harm. That is the zeroth law. And the first law is a robot must not harm a human being, or though inaction allow one to come to harm. And the concerning the second law, a robot must always obey human beings unless it is in conflict with the higher order law. And what is the higher order law? I'll tell you. And the third law is a robot must protect itself from harm unless that is in conflict with the higher order law. These are the 4 different laws. And once again, I am repeating the last zeroth law. A robot must not injure humanity, or though inaction, allow humanity to come to harm. And concerning the first law, a robot must not harm a human being, though inaction allow one to come to harm. A robot must always obeys human beings unless it is in conflict with the higher order law. And the third law, a robot must protect itself from harm unless that is in conflict with the higher order law. As these are the basic law of robotics that we should keep it in mind. Once we are talking about robotics, we should aware about it. And this is what we have already discussed about various grippers and all. And see the unilateral or multilateral gripper and the mechanical grippers. See, and holding part of mechanical gripper, and see the two finger mechanical gripper for grasping rotational paths, and parallel mechanical gripper and angular mechanical gripper. You can see the various nomenclatures, that is body, shaft, jaw, and pivot pin, piston, link, and T-bar. The various parts or nomenclatures related to angular mechanical grippers, and two or more fingers which a mechanical gripper consists. See, yeah. And here the gripper styles, that is parallel type mechanical grippers are available, and similarly we have angular grippers. And with the parallel grippers we can learn the forces which can hold the component. And see the work part and pad with shape of work part. The pad should have the part which we are going to take it from the base, and the finger and a gripper. Physical constraint method of finger design, and this is what we are going to learn. And see the W, that is weight of the grasped object, should be equal to the equal to the cross product of mu nf and fg. Mu nf and fg, this is what the formula. And the mu is in coefficient of friction of the finger contact surface against the part surface. The friction between the finger and the contact surface is mu, and the number of contacting fingers, if it is 2, then we'll take it as 2, or 3 is 3. Then gripper force is Fg, and the weight of the part or object being gripped, and that is W. And therefore, as shared by your friend, the gripper force is purely depends on the weight of the part or weight of the object. And once see here the coefficient of friction, and the coefficient of friction is clearly shown in the illustration. And the Fg, see the Fg, and when we have very weight component, that is Wg is in action, what we need to consider, and see G is a factor. The equation, let it be, this might be equation 1. The equation 1 must be changed if the weight of the work part is more than the force applied to cause the slippage. Then we need to consider a factor as G, and that is what here it was written, where G is factor. The G factor is supposed to take account of the combined effect of gravity and acceleration. And if the acceleration force is applied in the same direction as the gravity force, then the G is equal to 3. If the acceleration applied in the opposite direction, we need to take it as 1. That is 2 into weight of the part due to acceleration minus 1 into the weight of the part due to gravity. The acceleration is applied in the horizontal direction, then we need to take it as G. There are 3 possibilities for G. One, if it is against gravity, then we need to take it as 1. If it is parallel to gravity, then we need to take it as 3. when it is horizontally applied, then we need to take test 3. 1, 2, 3 we need to take. And these are the linkage actuations in mechanical gripper. And gear and rack actuation, we have cam actuation and screw actuation. And see, when we are trying to apply the force at the left end, what it does, it can hold the component which is on the other end, and instead applying the forces at 2 different points, we can make it as one by giving 2 pivots, and one joint we can make it as a single force can be applied. And this is some other typical example of linkages actuation. And see the gear and rack actuation in mechanical gripper. And this is cam actuation and the screw actuation. And these are the limitation of mechanical gripper. The dynamic force and moment when sizing gripper, and the gripper could draw apart with loose in air pressure, and the angular gripper are less expensive, but the arching motion of the jaw may require additional tooling clearance and will grip at varying points as part with varies. And these are the limitation of the mechanical grippers. And some specifications are given here. And from 0.1 lbs to over 1600 lbs, it can the force ranges, gripping force may range, and the part size, it can take the part with a size of 0.01 to 36 inch. In number of job is usually 4 till 4 we can do. And repeatability, see, and the number of cycles and supporting technologies, air value, air compressor, sensor, and IO interface. And the advantage of mechanical grippers, we have dual gripper and interchangeable fingers and sensor feedback to sense the presence of object. To apply a specified force to the object, we have a sensory feedback system. That feedback system allows us to take the specific object, and the multiple fingered grippers that is similar to human hand, we can do the standard gripper products to reduce the amount of custom design required. And hooks and scoops, and see the example for hooks and scoops. And we have magnetic grippers and suction grippers. See the suction grippers which was disseminated in the video, and vacuum grippers, and small to the medium object, and large heavy objects, and even it can carry the uneven objects. And the level of vacuum grippers and the vacuum gripper applications. Expandable bladder type gripper and adhesive grippers. See, this is the adhesive gripper which we have seen in the first video. And pneumatic or air operated gripper, and gripper force analysis. And that's all about today's presentation. And we'll a little more we will talk about the force and the design of grippers. We'll talk in the next class. And do you have any doubts with today's presentation? Dear gentlemen, when I am calling dear gentlemen, that includes both the sex, that it should not be a male. I'm making the female also. And is Vimalation, do you have any doubts with today's session?
Sir, test portions.
Test portion, we have tested during March.
March 3rd, I guess.
3rd, Chitesh, when we have the test?
Yes,
March
sir.
3rd.
March 3rd.
The content which we are disseminating till March 3rd will be the portion, Vimalation.
Okay, sir.
Okay,
Sir, and
how
what will
the
the
other?
question patterns be? Like theory based or numerical based?
Great, that is what I am inquiring. What was the other subject faculties are planning to have? Whether it might be a objective type or it might be a descriptive type.